Can you hear me now? Can you hear me now? Am I audible now? Okay, okay. I think now it's perfect. Chalo. Okay, thank you. Yaar. Bye. Let me know once in the chats quickly if all of you can hear me now. There was something wrong, some technical issue. Some technical issue was there. I think it's fixed. You just let me know in the chats quickly. Quickly in the chats. Quickly, people. Yeah? All right, all right. All right. I believe I am perfectly audible and visible to everyone now. All right, people. I was worried. I thought today's session is also over. Huh? It's gone. But now it's okay. So, people, today it's going to be the third part of the chapter chemical bonding, right? The third part of the chapter chemical bonding. And this is going to be the super important session, guys. Why it's going to be the super important session of the chapter? Because majority of the times when a question is asked from the bonding, that will come from today's session. 70% of the times when the questions are framed from the chapter bonding, they'll be framed from the topics which I'll be teaching you in the today's session. Okay? So please and please listen to this particular session very carefully. Whatever things I'll be mentioning on the screen, I would want you guys to take a note of every single thing. Every single thing, guys. Every single thing. Yeah? Perfect? Am I again not audible? No, I think I'm perfectly audible now. Okay, let's get going then. Yes, you have to refer the new NCRT, not the old NCRT. Refer the new one. Refer the new one. Hello guys, let's get going then. Let's get started with the today's topic. Just a second. Just a second. This is going to be our first topic of the today's session, which we are going to cover, right? Let me turn the dark mode on because these lights, they irritate a lot. Okay, just a second, guys. Just a second. Perfect. Now I think, yes, it's perfect now. So my dear students, our first topic which we are going to cover today, it's going to be the valence bond theory. Valence bond theory, right? What this valence bond theory exactly is all about. Let's try to understand. My dear students, this particular valence bond theory, it is going to explain us how exactly a covalent bond is formed. Till now, you only know one thing. You just know one thing. In the covalent bond, there is mutual sharing of electrons. That's something all of you would be knowing, right? But this theory is going to give us the actual definition. This theory is going to give us the actual meaning of the covalent bond. This theory is going to let us know how a covalent bond actually gets formed, right? So, from now onwards, you are going to remember one thing. Valence bond theory. It explains what? It explains the formation of covalent bond. Now, how exactly it explains the formation of covalent bond? There are a few things which you need to know, my dear students. There are a few things which you need to know. The first and the most important point of this particular theory, what is that? A covalent bond is formed by the overlap of atomic orbitals of the bonding atoms. What is meant by this particular statement? A covalent bond is formed by the overlap of atomic orbitals of the bonding atoms. Now here comes the term overlap. Here comes the term overlap. What is meant by the term overlap? My dear students, imagine that I have got two atoms with me. This is one atom, this is one more atom, right? How do we exactly define overlapping of these two atoms? Overlapping means penetration of atomic orbitals into each other. Overlapping simply means penetration of atomic orbitals into each other. Overlapping means the penetration of atomic orbitals of bonding atoms. Into each other. Penetration of atomic orbitals of bonding atoms into each other. That is something which we call as overlapping. And due to overlapping, what happens? Due to the overlapping of atomic orbitals of bonding atoms into each other, which bond gets formed? A covalent bond gets formed. What does it mean? Let's try to understand this a bit more in detail. First of all, I believe this particular term overlapping is clear to you, right? Imagine I have got two atoms with me, right? Now, when these atoms will come closer, that means their atomic orbitals are also coming closer. My dear students, there will be a scenario when atomic orbitals of both these bonding atoms, when those atomic orbitals will merge into each other. And that merging of electron clouds, those merging of atomic orbitals of these bonding atoms into each other is something which we call as overlap. For example, let's say this is the atomic orbital of one atom. And similarly, for example, this is the atomic orbital of one more atom. Let's say these two atoms have to form a bond. Which bond? Covalent bond. Let's say these two atoms, they have to form a covalent bond. Now, my dear students, in order to show a covalent bond, in order to form a covalent bond, what should happen? These atomic orbitals, they should merge into each other. And that merging of atomic orbitals or bonding atoms into each other is something which you call as overlapping, right? So in short, I would say, in order to form a covalent bond, these atomic orbitals should overlap, right? Now, my dear students, in order to show overlap, can I say these atoms should come closer? Yes, these atoms, they should start coming closer so that their atomic orbitals will merge into each other, right? So that their atomic orbitals will merge into each other. And when these atomic orbitals merge into each other, this merging of electron clouds or bonding atoms into each other is something which you call as overlap. And due to overlap, which bond gets formed? Covalent bond gets formed as per your valence bond theory is concerned. Due to overlap, covalent bond gets formed. So read the statement again. A covalent bond is formed by the overlap of atomic orbitals or bonding atoms into each other, right? What is overlap? Overlap is nothing but penetration of atomic orbitals or bonding atoms into each other, right? And once overlap of atomic orbitals or bonding atoms takes place, which bond gets formed? Covalent bond, as per your valence bond theory is concerned, right? Now, my dear students, something which I told you, in order to show overlap, these bonding atoms, they have to come close. They have to come close such that their orbitals can overlap, right? I believe these two statements are clear to you. Yes, I believe these 2 points are clear to you. Okay. So what is overlapping? It is basically defined as the penetration of atomic orbitals or bonding atoms into each other, right? And due to overlapping, covalent bond gets formed as per your valence bond theory is concerned. And this overlapping we have to discuss in detail. In detail, we have to discuss this overlapping. Okay? In detail, we have to discuss this overlapping. But before discussing this overlapping in detail, there are 2 more things which I'm going to tell you right now. Then I'll be discussing this overlapping in detail. 2 more things, my dear students. First one, we got to know, in order to show the overlap, atomic orbitals must come close. When the atomic orbitals come closer, there will be a scenario when the atomic orbitals of 2 bonding atoms, they'll merge into each other. That merging of electron clouds into each other, merging of atomic orbitals into each other, leads to the formation of what? Leads to the formation of covalent bond. Now, strength of the covalent bond, whether the covalent bond formed is stronger or weaker, strength of the covalent bond, that depends on the extent of overlap. My dear students, more the overlap between the atomic orbitals, stronger is going to be the bond. In short, so I would say strength of the bond is directly proportional to extent of overlap. It is directly proportional to extent of overlap. More the overlapping between the atomic orbitals, right? Stronger is going to be the covalent bond formed. Number 1. Number 2. My dear students, once this overlapping is done, for example, this is the atomic orbital of one atom, this is the atomic orbital of one more atom. Now, in order to make a covalent bond, these atomic orbitals of 2 bonding atoms, they must come close so that their atomic orbitals will merge into each other. And this merging of electron clouds into each other is something which we call as overlap. And due to overlap, which bond gets formed? It is a covalent bond which gets formed. Now, strength of the covalent bond depends on the extent of overlap. More the overlap over here, stronger the bond formed. Now, remember one thing. My dear students, once this merging is done, this electron density is common to both atoms now, right? This electron density is common to both atoms now. This electron density, it is going to arrange itself in such a way, that it comes under the influence of both the nuclei. As a result of overlapping, electron density will arrange itself in such a way that it is under the influence of both the nuclei. That means this common electron density, it has to come under the influence of both the nuclei. So the final shape over here, I'm going to represent like this. This is the common electron density, which is under the influence of both the nuclei. Which is under the influence of both the nuclei. Right? Nucleus of one atom, nucleus of one atom. Right? Now, this common electron density, it is under the influence of both the nuclei. Perfect? So, let me quickly summarize it. In order to form the covalent bond, the atomic orbitals of the bonding atoms, they should approach each other, they should come closer, right? Why they should come closer? Then only their atomic orbitals will merge into each other, and merging of electron clouds, merging of atomic orbitals into each other leads to the formation of covalent bond. Leads to the formation of covalent bond, right? And my dear students, once this merging is done, the electron density, it arranges itself in such a way that it comes under the influence of both the nuclei, right? Similarly, strength of the bond formed depends on the extent of overlap. More the overlap, stronger the bond. More the overlap, stronger the bond. Perfect. I believe till here, you got the general idea of how covalent bond is formed. Okay. Now, my dear students, let's try to understand this in detail. Let's get to know what are the types of the overlap. Let's get to know the types of the overlap. In how many ways overlap between the atomic orbitals can happen. Remember, my dear students, there are two types of overlaps. One is called as axial overlap. One is called as parallel overlap. Let me tell you this axial overlap. What does it mean? Whenever overlap between the atomic orbitals of the bonding atoms. Whenever the overlap between the atomic orbitals of the bonding atoms happens along the axes. That type of overlap is what we call as axial overlap. Whenever the overlap between the atomic orbitals of the bonding atoms happens along the axes, you call that overlap as the axial overlap, or this is called as head-on overlap. And let me tell you, due to the axial overlap, due to the head-on overlap, which bond gets formed? Covalent bond. And which type of covalent bond gets formed here? That is something which you call a sigma bond. So sigma bond is formed by the axial overlap of atomic orbitals, by the head-on overlap of atomic orbitals. Now, there is one more type of overlap that's called as parallel overlap, or you can call it directly as sideways overlap. My dear students, in case of parallel overlap, what happens? Overlap between the atomic orbitals takes place. Overlap takes place between the atomic orbitals of the bonding atoms by keeping their axes parallel. What is meant by this? I'll make you understand all of this in detail in some time. First of all, remember these words which I'm telling you. In case of parallel overlap, what is parallel overlap? In case of parallel overlapping, atomic orbitals are going to overlap by keeping their axes parallel. What is meant by this? In 5 to 10 minutes, you'll get the idea of all this, right? One thing which I want to tell you. Since there is overlapping happening, whenever there is overlapping, covalent bond is formed. Now, which covalent bond can get formed due to this overlap? That's something which I'll be calling as pi bond. Either a pi bond is going to get formed or a delta bond is going to get formed. So, my dear students, the first question which you are going to remember here, due to the axial overlap, which covalent bond is formed? Sigma bond gets formed. Due to the parallel overlap, which bond gets formed? Either pi or delta bond gets formed. Now, we are going to understand this axial overlap and parallel overlap in detail. In detail, my dear students, right? In detail. First of all, have a look on this particular statement. Axial overlapping. When two atomic orbitals overlap along their axes, it leads to the formation of the sigma bond, which I told you already, right? Now, in detail, we are going to discuss this axial overlapping. My dear students, the first type of axial overlapping is what you call as SS overlap. SS overlap. Now try to understand what this SS overlap exactly is all about. What happens in this SS overlap? See, what happens in this SS overlap? Try to understand very carefully. For example, imagine this is the s orbital of one atom, right? Imagine this is the s orbital of one more atom. And these two atoms, the two atoms which I have taken, the two atoms whose s orbitals I have taken, let's say a bond has to get formed between these two atoms. A bond has to get formed between these two atoms. This is the s orbital of one atom. This is the s orbital of one more atom, right? Now, my dear students, what exactly am I teaching you? I'm teaching you exactly the axial overlap. In axial overlap, what is going to happen? Overlap will happen along the axes, right? So these two atomic orbitals, these two s orbitals of two bonding atoms, they are going to approach each other along the axes. Let's call this as z axis. Let's call this as z axis, right? And generally z axis is taken as internuclear axis. Generally, z axis is taken as the internuclear axis, right? Now, what is going to happen? What is going to happen? The two s orbitals of two bonding atoms, they are going to approach each other. And when they approach each other, what is going to happen? They are going to show overlapping. They'll show overlapping. Tell me, is it head-on overlapping? Yes, it is head-on overlapping. This is going to be overlapping along the axes. Now, my dear students, two things can arise over here. Two things can arise over here. One overlap, I'll be calling as positive overlap. And one more overlap between these two atoms, that will be called as negative overlap. Positive overlap means this is also called as in phase overlap. This is called as out of phase overlap. This is called as out of phase overlap. And let me tell you, only the positive overlap leads to the formation of a bond. Only the positive overlap leads to the formation of what? Formation of a covalent bond. Negative overlap does not lead to the formation of the covalent bond. Now, my dear students, how exactly am I going to show you the positive overlap and negative overlap over here? What I'll be doing? I'll be giving certain signs over here to these orbitals. If I give this a positive sign, I'm giving this as the positive sign as well. Whenever you see same sign on same side, same sign, same side, same sign, same side, remember positive overlap is going to happen. If this was positive, this was negative. For example, if I had given this as the positive sign, if I had given this as the negative sign, this shows the negative overlap. What just happened? Okay. This shows over here the negative overlap. This shows the negative overlap. And negative overlap does not lead to the formation of any bond. It is only the positive overlap, in phase overlap, that leads to the formation of bond. Now, people, since these atomic orbitals, they are coming closer along their axis, there is going to be head-on overlapping, right? So let me show you this head-on overlapping. This is one atomic orbital. This is one more atomic orbital. This is the common electron density. So I would say, which kind of overlapping has happened over here? Should I be calling this as axial overlapping? Yes, this is something which I call as axial overlapping. This is something which I call as called as the head-on overlapping. And axial overlapping always leads to the formation of which bond? Axial overlapping always leads to the formation of sigma bond. But before that, let me tell you, this common electron density, as I told you, this common electron density now is going to arrange itself in such a way that it comes under the influence of both the nucleus, right? This is the common electron density. This is the common electron density, my dear students. This is the common electron density, right? The electron density has arranged itself in such a way that it is under the influence of both the nuclei, right? Right, people? Am I clear till here? Am I clear till here? Perfect. Now, this was one type of overlap. This was, I would want you guys to erase this one just to show you this. I showed you this negative overlap. Okay? And let me tell you, s orbitals particularly, they do not show the negative overlap. Why is that? I'll show you the logic in some time. I just wanted to tell you, whenever you see same sign on same side, whenever you see same sign on same side, remember it's positive overlap. Opposite sign, same side means negative overlap. Opposite sign, same side means negative overlap. Right? Okay. Let me tell you one more thing. Let me tell you one more thing. There is one more overlap, one more axial overlap, that is SP axial overlap. I'm talking about the axial overlapping, right? The first type of axial overlapping was SS axial overlapping. Second is SP axial overlapping. SP axial overlapping. Now, from the name itself, you will understand now what will be the SP overlapping all about. My dear students, imagine that one of the S orbital, the S orbital of one atom, and the P orbital of one more atom. This is the P orbital of one more atom, right? Okay, and this is the axis over here, which I'm calling as internuclear axis, which is generally which axis? This is Z axis generally. This is your Z axis. Now, is this going to be head-on overlapping? Yes, this is going to be head-on overlapping. And due to head-on overlapping, what's going to happen? Due to head-on overlapping, what's going to happen? What's going to happen? Due to head-on overlapping, what's going to happen? A covalent bond is going to get formed, right? Now, my dear students, there are two things which are going to happen over here. As I told you already, one is going to be the positive overlap, one is going to be the negative overlap. One is going to be the positive overlap, one is going to be negative overlap. How do you show the positive overlap over here? How do you show the positive overlap over here? My dear students, give it a positive sign, for example. Give this a positive sign. Give this a negative sign. Check. Same sign, same side. Same sign, same side. That means positive overlap. Positive overlap. Positive overlap leads to the bond formation. Positive overlap leads to the formation of bond. Now, these atomic orbitals, they are going to merge into each other. They are going to merge into each other like this. They are going to merge into each other like this. And this is the common electron density, I would say, over here. Since the atomic orbitals have merged into each other, right? So I would say overlapping has happened. What kind of overlapping is this? This is overlapping along the axis. And I'll be calling this overlapping as the axial overlapping. And axial overlapping always leads to the formation of which bond? It's the sigma bond. It is the sigma bond which gets formed over here. Right? Now, my dear students, if I will have to show the negative overlap, over here, what is something which I'll be doing? See, let's call this as S orbital of one atom. Give it a positive sign. Now, this is the P orbital of one more bonding atom. Give this the negative sign, but give this the positive sign. Do we have same sign on same side? No, we have got opposite sign, same side. Opposite sign, same side. So, it is going to be what? It is going to be negative overlap, and negative overlap does not lead to the formation of any sort of bond. Okay? Simple. Right, people? This was your SP axial overlap. Now, the third type of axial overlap is your PP axial overlap. Third type is going to be PP axial overlap. The third type is going to be your PP axial overlap. What happens in PP axial overlap? Try to understand. My dear students, this is one of the p orbital of one bonding atom. This is one more p orbital of one more bonding atom, right? And this is the internuclear axis, which is generally your Z axis. Perfect. Now, in order to show overlap, these atomic orbitals, they should come closer so that these atomic orbitals will merge into each other. For example, over here, I need to show the positive overlap. Let's say I need to show positive overlap. I need to show in-phase overlap. How exactly am I going to show in-phase overlap? Same sign, same side. So give it a positive, for example. Give this a positive. If this is positive, make it negative. If this is positive, make it negative. So same sign, same side. So it's going to be positive overlap. Now these atomic orbitals, they are going to merge into each other. And after merging, how they will look like? This is one of your atomic orbital. And this is your one more atomic orbital. So these atomic orbitals, they have merged into each other. Now this common electron density, as I told you, this common electron density, it is going to arrange itself in such a way that it comes under the influence of both the nuclei. So this common electron density, it will arrange itself in such a way that it comes under the influence of both the nuclei. So this is the common electron density, which is now under the influence. This is the common electron density, which is now under the influence of both the nuclei over here. What kind of overlap this was? This was the axial overlap. This was the head-on overlap. And head-on overlap always leads to the formation of which bond? It always leads to the formation of sigma bond. So over here, sigma bond has got formed. Now, my dear students, if I want to show the negative overlap over here, what you just have to do? You just have to change the sign. Let's say you are giving this positive, you are giving this negative. So over here, give this negative, give this positive. Opposite sign, same side. Opposite sign, same side. Opposite sign, same sign means negative overlap. and negative overlap does not lead to the formation of any bond. I hope this is clear to everyone. Perfect. So this was your axial overlapping all about. In case of axial overlapping, what happens? The atomic orbitals, they are going to overlap along the axes, right? They are going to overlap along the axes. Perfect. And once overlapping is done, then electron density is going to arrange itself in such a way that it comes under the influence of both the nuclei. Due to the axial overlapping, which bond gets formed? Covalent bond. Which type of covalent bond? It's going to be the sigma bond which gets formed, right? And this axial overlapping, it can happen in two ways, either positive overlap or negative overlap. Positive overlap leads to the formation of bond. Negative overlap does not lead to the formation of bond. Positive overlap means same sign, same side. Negative overlap means opposite sign, same side. That's all. Done and dusted. Yeah? I believe I'm clear. I believe I'm clear. Okay, I believe I'm clear. So this was your SS overlap. Perfect. This was your SS overlap. This was your SP overlap. This was your SP overlap. And which type of SP overlap? SP axial overlap. And this was your PP axial overlap. This was your PP axial overlap. Right? This was your PP axial overlap. Now, my dear students, let's talk about the parallel overlapping. Let's talk about the parallel overlapping, which leads to the formation of pi bonds and delta bonds. Parallel overlapping. As I told you, due to parallel overlapping, what happens in parallel overlapping? Atomic orbitals, they are going to overlap by keeping their axes parallel. Atomic orbitals are going to overlap by keeping their axes parallel. And due to the parallel overlapping, which bond gets formed? Either pi or delta. Either pi or delta. Either pi or delta. Let's try to understand this in detail. My dear students, the first type of parallel overlapping which I'm teaching you over here, that will be called as PP parallel overlap. PP parallel overlap. Now, what happens in this PP parallel overlap? Try to understand. See guys, consider this as your internuclear axis. Consider this as your internuclear axis. And internuclear axis is generally taken as Z axis. So this is your Z axis, right? Let's say, my dear students, I have to show PP parallel overlap. Let's say this is the p orbital of one atom. Okay. Let's say this is p orbital of one more atom. If this is Z axis, call this as py, call this as py, right? Call this as py. Perfect. Now, my dear students, what is going to happen over here? What is going to happen over here? I have to show PP parallel overlapping. So these atomic orbitals, these p orbitals, they have to overlap by keeping their axes parallel. They have to overlap by keeping their axes parallel. Again, over here in this particular case, my dear students, two things can arise. Two things can arise. One is going to be positive overlap, one is going to be negative overlap. Let me first of all show you the positive overlap. Let me first of all show you the positive overlap. If this is positive, for example, this is going to be negative. If this is positive, this is going to be negative. Do we have same sign on same side? Yes. Same sign, same side. So which overlap am I showing you over here? I'm showing you the positive overlap. In phase overlap. I'm showing you the in phase overlap. Now, my dear students, what's going to happen? They are going to come closer with their axes parallel. So, for example, this is one of the p orbitals, right? And similarly, this is one more p orbital. So, do you see any overlapping here? Yes, overlapping has happened. Yes, overlapping has happened, right? Yes, overlapping has happened. What kind of overlapping this is going to be? This is the parallel overlapping, right? This is the parallel overlapping. Now, my dear students, as I told you, this common electron density, it's going to arrange itself in such a way that it comes under the influence of both the nuclei. So how you are going to show it at the end? See, basically, this is how you are going to show. Imagine this is one of the plane over here. Imagine this is one of the plane over here. One plane I'm showing you. The electron density will be above the plane and the electron density will be below the plane. Above the plane and below the plane. This is the plane which I'm talking about. The electron density is above the plane and below the plane. So this is how I'm going to represent it. This is the electron density which is above the plane, and this is the electron density which is below the plane, right? This is below the plane. So first of all, what kind of overlap this was? This was your parallel overlap. Parallel overlap leads to the formation of covalent bond. Which type of covalent bond? This is going to be your pi bond. This is going to be your pi bond. And my dear students, this pi bond which got formed over here, this is something which I call as p pi bond. I'll be calling this particular bond over here as p pi bond. P pi bond, right? Now people, have a look. See, imagine this is the nucleus of the atom. This is the nucleus of the atom. So the two nuclei I'm going to represent over here. This is nucleus of 1. This is nucleus of 1 more. If I ask you, on this plane, do you see any electron density? On this plane, do you see any electron density? There is no electron density on this plane. The electron density is above the plane and below the plane. There is no electron density on this plane. That plane which does not contain any electron density, you call that plane as the nodal plane. So how many nodal planes you have here? There is one nodal plane here. There is one nodal plane here. Yes? Perfect. So this was your positive overlap. Now, what about negative overlap? How you are going to show the negative overlap? Just let me show you. Let's say this is your P. This is your P. Give this positive, give this negative. Give this negative, give this positive. Opposite sign, same side. Opposite sign, same side. Which overlap this is going to be? Negative overlap. And negative overlap does not lead to the formation of any bond. Perfect. Right? I believe I'm clear. I believe I'm clear. Perfect, people. So this was your PP parallel overlap, which leads to the formation of pi bond, right? Now, the second type over here. The second type of parallel overlapping is going to be your PD parallel overlap. The second type of overlap is going to be your PD parallel overlap. Okay? For example, my dear students, this is one of the p orbitals. This is one of the p orbitals, right? And I'm taking d orbital of one more bonding atom. This is the d orbital of one more bonding atom. Okay, this is the d orbital of one more bonding atom. Perfect. Now, first of all, these two, this p and d, which kind of overlap we are going to show? We have to show the parallel overlap, right? We have to show the parallel overlap. So first of all, it can happen in two ways. One is going to be positive, one is going to be negative. And over here, I'm just going to show you the positive overlap. Negative, I believe you can easily do. You can easily show negative overlap. Positive means in phase overlap. In order to show in phase overlap, give these lobes the signs. Give it positive, give it negative. If this is positive, then this has to be positive. If this is positive, then this has to be negative. If this is negative, then this has to be negative. If this is negative, then this has to be positive. Look, same sign, same side. Same sign, same side. Now, which kind of overlap they are going to do? They are going to show the parallel overlap, right? How you are going to represent it? This is your P. And these are the lobes of D which have merged into this P. These are the lobes of D which have merged into P. Perfect. So what kind of overlap this is? This is again the parallel overlap. Parallel overlap leads to the formation of pi bond, right? So over here again pi bond has got formed. And which type of pi bond this is going to be? This is the pi bond formed between P and D. So you call this overlap as, you call this pi bond as P pi D pi bond. You call this as P pi D pi bond. And I believe you can easily show the negative overlap over here, right? I believe you can easily show the negative overlap.